Okay, so section 11.4 is on geometric sequences and series. So we've talked about the arithmetic sequences and series. So arithmetic, add, geometric is going to be multiply. Okay, so geometric sequence is a sequence in which consecutive terms have a common ratio. So for the sequence A1, A2, A3, A4, A5, the common ratio R is just any number divided by the number before it. So remember how that common difference was any number minus the number before it. So my common ratio is going to be A5 divided by A4, which is the same as A4 divided by A3. So same thing, which is A2 over A1. So any number divided by the number before it. Okay, so are the following sequences geometric? If so, what's the common ratio? So personally, I think the easiest way to find the common ratio, I think it's to take the number and say, what do I multiply the first number by to get the second number? 2. Okay, how about the next one? 2. 2. Yep, common ratio is 2. So yes, ratio is 2. How about the next one? Yeah, there's a 3 on the bottom, right, that you're multiplying by 3. So what's it going to be? 1/3, right? So you're always multiplying by 1/3. So that's your common ratio. So you can check, you always multiply by 3 on the bottom and 1 on top. Okay, the nth term of a geometric sequence. The nth term of a geometric sequence has the form a sub n equals, okay, this is very similar to what we did with our arithmetic sequence. Do you remember when we had an arithmetic sequence? So when I had like 1, 3, let me do something harder than that. When we had like 1, 4, 7, 10, and so on, you always added 3. So we said, okay, it's going to be my first term plus however many of the common differences. Okay, for our ratio, we're going to do the same thing. We're just going to say, okay, I'm going to start with my first term, and if I want to get to the nth term, I'm going to multiply by r how many times? N minus 1, right? Because if I'm at the first term, it takes 1 swoop to get to the second term. Remember all that? Swoops, yeah. All right, so that's our formula. So number 1, it says find the common ratio of the geometric sequence with A1 is equal to 3 and A2 is equal to 12. So what's the common ratio? So I can see that I just multiplied by 4. Oh goodness. There we go. My cord gets low. Okay. So we're going to list the first 5 terms of the sequence. Okay, this is easy enough. I mean, you can just list them. You can say, okay, my first one's 3, my next one's 12. I'm going to keep multiplying by 4. So 48. What do I get when I multiply by another 4?
192.
192. And then multiply by another one?
760.
You could always multiply by 2 and then multiply by 2 again. That works double. Yeah. All right, so those are the first 5 terms. All right, number 2, write a formula for a geometric sequence where the first 2 terms are 3 and -3/4. Find the first 5 terms of the sequence. Okay, this one's going to be a little harder. Okay, so my first one is 3. My next one is -3/4. So what am I multiplying by? -1/4, right? So think the numerator is being multiplied by a -1, denominator is being multiplied by 4. Okay, so let's find the other terms. So if I have -3/4 and I multiply it by -1/4, what happens? +3/16, right? How about by another one? -3 now. 64, right? Another one? +3 and 256. Yes. Okay. All right, so those are the first 5 terms of the sequence, but we actually need a formula. So if I wanted to find the nth term, so a sub n, I start with my first term, which is 3, and I multiply by my common ratio, so negative 1/4, n minus 1 times. Okay, so that should make sense based on what we did yesterday. So if I'm already at the first term, if I want to get to the second, I just do one of those little swoop things. I just multiply once. If I want to get to the third term, I'd have to multiply twice to get there. If I want to get to the fourth, I multiply by it 3 times. Okay, so that's why this formula is like it is. Now, on the test, this is not negative 3/4 to the n minus 1. Why can I not multiply 3 by negative 1/4? Yeah, you have to do exponents first, right? Exponents. Yeah, you have to do exponents first. So that's the please excuse my dear Aunt Sally thing, your order of operations. All right. Okay, the 4th and 7th terms of a geometric sequence are negative 18 and negative 486. So this goes back to the don't be a slave to the formulas, like the last chapter, right? Don't just memorize this formula right up here that I'm putting a red star next to. Don't just memorize that, because sometimes you're not given the first term. You're given the 4th and the 7th. So you got to figure out how to relate them. So you're, well, not n minus 3, close. Okay, so you're going to have a sub 7, so the 7th term. I get to that by starting with the 4th and multiplying by r how many times? 3. So just like before, see how n minus 1 and 1, they added to be what you're trying to find, n? Same thing here. 3 and 4, they add to be what you're trying to find, 7. Okay? All right, so I have a sub 7 is negative 486. A sub 4 is negative 18. R, we don't know. We're trying to find. And it's being raised to the 3rd. You don't have to put that in parentheses. Okay, divide by negative 18. So do negative 486 divided by negative 18. What do you get? Yep, so you have 27 is equal to r cubed. How do I solve for r? Cube root. Do I need plus or minus? No. Why do I not need plus or minus? It's cube, right? So it's 3 equals r. So the cube root of 27 was 3. Okay, that gave you r. Now I need to find the 6th term. So just like yesterday, you can use either the 4th term or the 7th term to find it. It doesn't matter. So let's say we use the 4th term. What's the equation we're going to use? Yes. So also a sub 6 equals a sub 4 times r squared. Okay. Of course, my pen's not writing. Let's see. Okay, so a sub 6 equals a sub 4 r squared. Okay, so a sub 6 is what we're trying to find. A sub 4 was negative 18. R was 3, and we're squaring it. So I get 3 squared is 9 times negative 18. So what do we get? Yep, that's exactly right. Okay, makes sense? Nope. It's a sub 6. It's a subscript. So it's telling you what term it is. Yeah. Okay. So the question is, why don't we use the method we used before? This is called a geometric sequence. So these ones you're always multiplying by each term. So these are like 3, 12, 48, 192, 796, or 768, I mean. We're multiplying by 4 each time. We're not adding 4. So that's the difference. And that's the big thing on the test, guys, that people will mess up, is they feel really confident when they do each section one at a time, but then when they get to the test, they can't remember which one goes with which. So always think, am I multiplying each time, or am I adding? Which one am I working with? Okay. All right, if the common ratio is 1, then you'll have the same term every single time, right? Does it make sense? If your common ratio is 1, you're always multiplying by 1. So if my first term was 5, my next term would be 5, 5, 5. Okay, so then if I'm adding up k of those same things, what would your answer be? So let's say I had 5. So if my first term's 5 and my common ratio is 1, I'd have 5, 5, 5, 5. So if I did it k times, I'd have 5 what? Close, that'd be multiplication. It's 5 times k. We're talking about the partial sums now. So adding up each term of your geometric sequence. So just 5 times k. All right, but the common ratio is not always 1. So when it's not equal to 1, so that's why I have r does not equal to 1. Then the sum of the first n terms. It's a weird formula. I give this to you on your test. It's a sub 1 times 1 minus r to the n all over 1 minus r. Sometimes people pull out the a to the 1 in the front.
I said it's r to the 1 minus
A sub 1. I said what now?
I thought you just said r to the 1 minus n.
I don't know what I said.
So it's 1 minus r.
1 minus r to the n. Yeah, did I say it wrong? Okay, so that's that. Either way you want to write it, doesn't matter. I'll give you, I think on the test it looks like this. Okay, so number 1, find the sum. So how many terms do I have?
1, 2, 9.
So n equals 9. There's 9 terms. So I'm finding the sum of those 9 terms. What's your first term? A sub 1. Okay, then I'm going to do 1 minus r to the n. What's r? Negative 1/2, right? That's r. You're multiplying by negative 1/2. So put that in parentheses. Negative 1/2 is your r. It's being raised to the n, which we said was 9, divided by 1 minus negative 1/2. Okay, make sure you're putting parentheses around your r, especially if it's negative. Okay, so it's a little tricky just because there's fractions, so some of you guys have fraction phobia, so you're freaking out. It's not too bad, though. Okay, so we can use our calculator. So get your calculator out. I'm going to do 1 minus, so this is what I'm putting in, 1 minus, parentheses, negative 1/2, raised to the 9. So I'm putting that in first. Okay, when I do that, I get a weird decimal number. 1.001953125. All right, now you could have put parentheses around all of this and did it all at once, but I usually like to kind of break things up, I don't know, just to make sure that you're doing each step right. What's the bottom going to be? It's what? 1.5. Do you guys see that the bottom is 1.5? Because you have 1 plus 1/2, right? 1.5. So divide your answer. So do answer divided by 1.5. So when you do that, you get 0.6679687. All right. And then multiply by negative 5/2. So times, yeah, or you could do negative 2.5, right? So negative 5 divided by 2. So when I do that, I get negative 1.66992. Okay, I'd always try to do the math one, so change it to a fraction. The fraction answer is always much nicer. Okay, so I want the exact answer, the fraction answer. So math, and then 1, and then hit enter. Okay, so that brings you to the question that you guys were always asked when you were little. You guys ready? Would you rather get paid $10,000 every day for 30 days, or get paid 1 cent the first day, 2 cents the second day, 4 cents the third day, until the 30th day?
2 cents.
I don't know. I could have changed the numbers. I could have made this.
What?
Let's see. Which would we rather have? Okay, so 10,000 each day. Okay, so let's say, all right, there's a big debate. Okay, how many say $10,000 each day? Raise your hand.
I'm just doing that.
I want 10 G's.
How many say 1 cent, 2 cent? So not very many of you want the 1 cent, 2 cents, 4 cent. Okay, we'll see. It could be close. All right. So if I have $10,000 each day for 30 days, that's just 10,000 times 30. So you get 300,000. That's not bad. I wouldn't mind $300,000. All right, let's try the second one. So let's do 1 cent, 2 cent. So let's do the other one. Okay, so if I do that one, this is the sum of a finite geometric sequence. We're going to use our formula. What's your common ratio? R is 2. What's A1? We're going to do it in dollars. So A1 in dollars is 0.01. All right, what's N? 30, because 30 days. So 30 things you're adding up. All right, so when we do this, this is going to be the sum of the first 30 days would be A sub 1, so 0.01, times 1 minus R is 2, so 2 to the 30th, divided by 1 minus 2. Okay, so let's do that all at once. So I'm going to do a parenthesis, 1 minus 2 raised to the 30th, parenthesis, divided by parenthesis 1 minus 2, which is obviously negative 1. And then times, or you can find that answer if you want, so answer. And then times 0.01.
Wow. I was right.
You get 10 million, over $10 million.
All right.
So we'd rather do that. Okay, everybody have that down? Okay, I'll give you a second to write it.
We still make 300,000.
That's chump change. 10 million, yeah. You have to do 2 to the 30th first. It's not 1 minus R, it's R to the N, and then 1 minus that. Okay. All right. You probably just forgot to divide by your negative 1, the 1 minus 2 part. This part. Okay, so the sum of an infinite. All right, so you can actually add up an infinite number of terms and get something that is not infinity, right? Do you guys remember that example we did the other day where we had 0.6 plus 0.06 plus 0.006?
Yeah.
And it went on to infinity, right? When we added it together, we got 0.6 repeating or 2/3. So we can add an infinite number of things together as long as the absolute value of R is less than 1. So as long as your ratio is something very small. Makes sense? So you're always getting smaller when you're multiplying by 1/2. Okay, so your number is always getting smaller. Okay, this is because as n gets very large, which means a small fraction raised to n, it becomes almost blank. So think about it. If I have n, which is a huge number, and I have a small fraction raised to this huge number, try that on your calculator. So try 5 million. Yeah, your calculator can't even calculate it, it's so small. So it just gives you 0, even though that's a rounding error. All right, so when you have a small number and you're multiplying by itself a ton of times, so n is huge, it becomes almost 0. So therefore, the equation that we had before, this part right here, r to the n, becomes 0. So it's just a sub 1 times 1 minus 0 over 1 minus r, which is a sub 1 over 1 minus r. Okay, so that's your formula. So a sub 1 over 1 minus r. I'll also give you guys that one on your test. So it'll be on your test for you. You need to know the difference, though. That's the infinite one. No, not for all of them. Nope, just for geometric. All right, so compute the following infinite sums. So if I have 1/2 plus 1/4 plus 1/8 plus 1 over 16. Okay, what's r? 1 half. What's a sub 1? 1 half. All right, this goes on forever. That's why you have the dot, dot, dot. So your sum, which we just call s now, we don't do sum of infinity or anything. We just say s, is equal to a sub 1, which is 1 half, divided by 1 minus r, which is 1 half. So if you need to write r equals 1 half, a sub 1 equals 1 half to see where we got those, you can. So I have 1 half divided by 1 minus 1 half, which is also 1 half. So I get 1. Okay, geometrically, let's see why this is true. Okay, let's say I have a grid. So this is the length from 0 to 1. Okay, my first number is 1 half. So that's filling in this much of my piece right there. All right, then I'm going to add in 1/4. What? Did I say something wrong?
No, look at this.
Okay, so if I add in 1/4, how much of the other part that isn't filled in? Half of that, right? So you fill in that much. So that was 1 half plus another 1/4. Now when I add in 1/8, what happens? Half of that, and then 1 over 16, that's half of that. So do you see how it's going to finally fill in? Well, it's going to keep getting closer and closer and closer. So if I have an infinite number, it's going to fill in that whole length from 0 to 1. Make sense? All right. So the last one, it's written a little bit differently. You might need to write out the first couple terms to see what's going on. So if I plug in 0, I have 2 times negative 2/3 to the 0. So that's the first term. Yeah, it's just 2. All right, what's your next term? 2 times negative 2/3, right? You'd have one of those. So 2 times negative 2/3 is negative 4/3. And then you'd multiply by another 2/3, negative 2/3. And then another one and another one. Okay, so your A1 is 2. Your R is negative 2/3. That's what you're always multiplying by. That's why it's there. Okay, so let's figure out the infinite. So I have A sub 1. A sub 1 is 2 over 1 minus R is negative 2/3. So I get 2 over 1 plus 2/3. Let's try to do it without a calculator. What's 1 plus 2/3 as a fraction? 3 over 3. 5/3, right? So I have 2 divided by 5/3, which is 2 times 3/5. So my total answer is 6/5. You got it. All right. Is that the last example in that section? Does it make sense? So just don't get the geometric and the arithmetic confused. That's the big thing.